Every single day, floating somewhere in the freezing vacuum of space between Earth and the Sun, thousands of ancient rocks are quietly colliding with each other. Most of them burn up harmlessly as shooting stars, but tons of cosmic debris actually survive the fiery plunge through our atmosphere and slam directly into the dirt, oceans, and ice caps of Earth. To most people, a rock on the ground is just a worthless piece of stone you kick out of your shoe while walking the dog. But to a small, dedicated group of cosmic treasure hunters, finding the right rock on the ground is the equivalent of hitting the literal multi-million-dollar space lottery. Welcome back to Cosmic Clueless. Today, we are strapping on our heavy boots, grabbing our high-powered industrial magnets, and taking our unluckiest Stickman proxy on an epic quest to find real space rocks, avoid hilarious scams, and answer the ultimate question: how do you spot a genuine meteorite, and can it actually make you stupidly rich? Before we send our Stickman into the scorching desert with a metal detector, we have to talk about the insane economics of the meteorite market. Why would anyone pay $10,000 for a dusty black stone that looks like a burned meatball? Well, unlike gold or diamonds, which are formed right here under Earth's crust, meteorites are literally pieces of other worlds. They are time capsules left over from the formation of our solar system 4.6 billion years ago. Some of them come from the iron cores of shattered protoplanets. Others were blasted off the surface of Mars or the Moon by giant asteroid impacts millions of years ago, floating through space before finally crashing right into someone's backyard. Because of their extreme rarity and scientific value, collectors, universities, and wealthy billionaires pay astronomical prices for verified specimens. A common stony meteorite, known as a chondrite, might sell for a few dollars per gram. But if you happen to stumble across a rare slice of a Martian meteorite, the price can skyrocket to over $1,000 per single gram. That means a small stone the size of a golf ball could be worth more than a brand-new sports car. Now, picture our Stickman proxy hearing this incredible news on the internet. His eyes instantly turn into giant green dollar signs, his jaw hits the floor, and he immediately quits his boring office job, sells his house, buys a cheap metal detector, and marches straight into the nearest rocky canyon, convinced he will be a billionaire by lunchtime. But finding a real meteorite is not like picking up berries in the woods. Earth is covered in billions of ordinary terrestrial rocks, volcanic basalt, slag from industrial factories, and rusty scrap metal. In the meteorite hunting world, these fake imposters are known as meteor-wrongs. For every single real space rock a prospector finds, they will pick up roughly 10,000 meteor-wrongs. Our eager Stickman starts waving his metal detector across the dirt. Suddenly, the machine goes wild, screaming with high-pitched electronic beeps. Our Stickman drops to his knees, frantically digging into the hard dirt with his bare hands, sweating profusely, imagining his new luxury yacht. He pulls out a shiny, heavy metallic object, only to realize it is a rusted, crushed soda can left behind by campers in 1992. Frustrated, he kicks a sharp boulder, stubbing his big Stickman toe so hard that his whole foot swells up like a red balloon while his metal detector short-circuits and catches fire in his hand. Classic amateur luck. So, how do professional meteorite hunters actually distinguish a priceless rock from a useless piece of junk metal? It all comes down to 5 strict physical tests that every real space rock must pass. If you want to hunt space treasures yourself, you need to memorize these rules because nature leaves very specific footprints on rocks that fell from the sky. Rule number 1 is the fusion crust. When a meteorite plunges through Earth's upper atmosphere at 30,000 miles per hour, the extreme friction creates temperatures exceeding 3,000 degrees Fahrenheit. This intense heat melts the outer layer of the rock in a fraction of a second. As it slows down and cools, this liquid layer hardens into a paper-thin, dark brown or pitch-black glassy shell called a fusion crust. If your rock is light gray, bright white, or covered in sharp, rough quartz crystals, drop it immediately. It never saw the upper atmosphere. But what happens when our Stickman finds a dark rock that looks exactly like it has a fusion crust, only to discover a terrifying secret hidden inside? Let us move on to test number 2 and see if our stickman can survive the dreaded magnet test. Test number 2 is the famous magnet test. Almost 99% of all meteorites contain a high concentration of metallic iron mixed with nickel. Because of this heavy metal content, a real space rock will almost always attract a strong magnet. Professional hunters do not use ordinary refrigerator magnets. They carry high-powered, rare earth neodymium magnets attached to the end of a walking stick. As they stroll through dry lake beds or deserts, they tap every suspicious dark rock. If a rock sticks firmly to the magnet and hangs in the air, you are one step closer to the jackpot. Naturally, our stickman proxy decides to take this test to the absolute extreme. He buys an overpowered, industrial-grade neodymium magnet the size of a dinner plate from a shady online warehouse. He marches back into the desert, holds out his giant magnet, and turns on the power switch. Instantly, the magnet creates a massive, supercharged electromagnetic field. But instead of pulling a tiny space rock from the dirt, the magnetic field locks onto a 600-pound metallic iron meteorite buried 10 feet underground. The magnetic force drags our stickman through the dirt at 50 miles per hour, slamming him headfirst into the buried rock, crushing his ribs, flattening his stickman nose, and pinning him completely upside down against a boulder. He is stuck like a fly on sticky paper, unable to reach the turn-off switch as his pants begin to smoke from the sheer magnetic tension. Classic stickman engineering. Once you free yourself from your oversized magnet, it is time for test number 3, the density and Regmaglypts test. Because meteorites are packed with dense metallic iron, they feel significantly heavier than an ordinary earth rock of the exact same size. If you pick up a stone the size of an apple and it feels like a heavy lead weight, that is a huge green light. Furthermore, as the outer surface of the meteor melts and burns during atmospheric entry, swirling air currents scoop out shallow, oval depressions in the rock. These unique markings look exactly like someone pressed their thumb into soft modeling clay. Scientists call these thumbprints Regmaglypts. If your heavy, magnetic black rock has shallow thumbprints all over its surface, congratulations, you are officially holding a piece of another planet. But wait, before our stickman starts booking a 5-star vacation to Hawaii, he has to pass test number 4, the streak test. This is where thousands of amateur hunters get completely tricked by common earth minerals like hematite or magnetite. Hematite is a heavy, dark, magnetic iron ore found all over Earth's crust that looks dangerously similar to a real meteorite. To expose this fake imposter, prospectors take the rock and firmly scrape it across the unglazed ceramic back of a white toilet tank tile. If the rock leaves a dark reddish-brown or black streak on the white ceramic, it is an earth mineral filled with iron oxide, a total meteor-wrong. A real meteorite will leave no streak at all, or only a very faint gray mark. Our stickman sneaks into a public restroom with a suspicious heavy rock he found in the parking lot. He takes off the heavy ceramic lid of the toilet tank, pulls out his rock, and violently scrapes it across the porcelain to test for a streak. But he presses way too hard. The heavy stone shatters the ceramic lid into sharp pieces, breaks the internal flush mechanism, and triggers a massive high-pressure geyser of dirty water. The explosive water jet launches our stickman straight through the ceiling of the restroom, blasting him into the open sky, wrapped in toilet paper and soaking wet. He lands at a nearby tree, coughing up water, while holding a worthless piece of industrial slag from a nearby steel mill. But what if you cut open your rock and find something so breathtakingly beautiful that it looks like a piece of cosmic jewelry? This brings us to the absolute holy grail of the space rock world: Pallasites. Pallasites are an extremely rare class of stony iron meteorites that consist of a solid nickel-iron matrix embedded with large, gem-quality olivine crystals. When scientists slice these rocks into ultra-thin plates and polish them, light shines directly through the translucent green, yellow, and amber crystals. Slices of Pallasites are so visually stunning and insanely rare that collectors pay tens of thousands of dollars for a single, small, square inch. Our stickman, now wearing a full-body bandage from his toilet explosion, decides to take a diamond saw to a heavy rock he found in his backyard. As the high-speed diamond blade cuts through the outer shell, glowing golden-green crystals catch the sunlight. Has our stickman finally found a multi-million-dollar Pallasite? Or is he about to get crushed by the ultimate legal loophole of meteorite ownership? Before our stickman starts picking out color options for his brand-new luxury supercar, he needs to understand the most critical step of all: chemical verification and legal ownership. You can pass the magnet test, the streak test, and find smooth thumbprints on your stone, but until a certified scientific laboratory analyzes the rock under an electron microscope, it is officially classified as an unidentified flying object. Real meteorites contain a unique chemical signature that is almost impossible to replicate naturally on Earth: a high percentage of elemental nickel. Scientists slice off a tiny sample of the rock, polish it to a mirror shine, and wash it with a special solution of nitric acid. If the rock is a metallic iron meteorite, the acid reveals a brilliant interlocking crisscross crystal structure known as the Widmanstätten pattern. Named after the Austrian scientist who discovered it, this mesmerizing geometric pattern can only form when nickel-iron alloy cools down in the vacuum of space at an excruciatingly slow rate of just 1 degree every million years. No lab on Earth can fake a Widmanstätten pattern. It is the universe's absolute seal of authenticity. Our stickman, filled with nervous excitement, packages his gorgeous crystal-filled stone and sends it directly to the National Space Geology Institute for official testing. 2 weeks later, he receives a formal letter, sealed in a golden envelope. He tears open the envelope with trembling hands and reads the lab report out loud. Congratulations! Your specimen is an authentic, highly rare, stony iron Pallasite meteorite. Estimated market value: $850,000. Our stickman jumps into the air, doing high kicks, screaming at the top of his lungs, throwing confetti into the room, and celebrating his newly acquired millionaire status. But then he turns the lab report over and reads the fine print on the back page, and his heart drops straight into his stomach. This brings us to the dark, complicated legal side of space treasure hunting. Who actually owns a meteorite when it falls from the endless expanse of the universe onto Earth? The answer depends entirely on where your feet were standing when you picked it up. In countries like the United States, meteorites belong to whoever owns the land where the rock landed. If you find a space stone on public government land, you may need special permits. And if you find it on private land without permission, the landowner can sue you for trespass and confiscate the rock entirely. In other countries, like Australia or Canada, all meteorites are strictly considered national scientific treasures. It is completely illegal to keep, sell, or export them out of the country without heavy prison sentences. And where did our unluckiest stickman find his $850,000 Pallasite? Right in the middle of his neighbor's flower bed, right under a giant neon sign that says, "Warning, private property. All space debris belongs to neighbor." Within seconds, his neighbor bursts through the door holding a lawnmower, snatches the certified space rock, and legally kicks our stickman off the lawn. Our poor stickman ends up lying in the dirt outside, broke, beaten, covered in bandages, holding nothing but a $20 fine for trespassing. Classic stickman destiny. But for real-world prospectors who follow the rules, hunt in legal locations like public deserts or Antarctica, and build relationships with landowners, searching for space rocks remains one of the most exciting adventures on Earth. You're not just looking for valuable metal. You're touching a piece of cosmic history that spent billions of years traveling through the dark silence of space before falling right at your feet. So the next time you're walking through a rocky field or hiking up a mountain, keep your eyes on the ground. That weird, heavy, burnt-looking black stone sitting in the mud might just be a worthless piece of slag. Or it might be a ticket to planetary fame and fortune. Would you sell a real piece of Mars to buy a mansion? Or would you keep it on your desk to flex on your friends? Drop your answers in the comments below. If you enjoyed this guide to space treasures, magnetic disasters, and stickman heartbreak, smash that like button, subscribe to Cosmic Clueless, and hit the notification bell. Keep your magnet strong, watch your step on private property, and we will see you in the next episode.